Resolving forces. Let's look at an example first off where this would be useful. Let's say you have to build a bridge, and your bridge is supported by two cables. Both of these are going to be under tension. You know the breaking strength of these cables, but you also know that this cable pulling this direction would be giving a vertical component to its pull and a horizontal component to its pull. You want the vertical components of each of these to equal the weight of your bridge, and you want the horizontal components to be balanced so that you don't end up with your bridge being pushed to one side. Now, to do this, we need to be able to turn our force at an angle into components. At 90 degrees to each other. Occasionally this is called orthogonal components. Now, to do this, what we need to do is we need to be very certain about our trigonometric functions, i.e. you need to be familiar with sine, cosine and tangent functions. And for resolving forces, we are interested in the sine, which is the ratio of the opposite over the hypotenuse, and the cosine, which is the ratio of the adjacent over the hypotenuse. Let's take an example of this. So here is our force. We're going to give it a label T, and we want to split this into two components. We want the horizontal component and we want the vertical component. Now, as you can see, when we take these and draw them as a vector diagram, i.e. we draw arrows tip to tail, then they should make a right angle here, and they also should join up to the top of our arrow. Now, we can split this into two components, and for this I'm going to use two colours. Our horizontal component. Our horizontal component, we need to look at what parts of our triangle we've got. So I've got a T, I want this, and I should have an angle. Here we're just going to give our angle the symbol theta. I'm going to use the general term for the time being. So here we can see we have got a hypotenuse and we've got our adjacent side to it. Adjacent means it's next to the angle. So to get our horizontal component, we are going to need to be using cosine, because we've got adjacent and hypotenuse. Cosine of our angle is equal to our adjacent divided by our hypotenuse. I'm going to put all the information in that we've got. So cos of our angle is equal to the adjacent, which is the thing we want, divided by the tension, which gives us our adjacent thing. Our horizontal component is going to be T times cosine of our angle. Now we may sometimes write this as TH for horizontal, or equal to T cos theta For our vertical components, we do pretty much the same thing. We draw out a little triangle. We don't really want. We're not interested in this side. We're interested in this side, which is opposite. This side is hypotenuse. We've got a t, we've got a theta. So here, our vertical component is going to be using the opposite and the hypotenuse. So the function that uses opposite and hypotenuse here is the sine. So we've got sine of our angle is equal to our opposite divided by our hypotenuse, which in this case is equal to opposite divided by t. We want just the opposite, so we need to rearrange for this. So my opposite is going to be t times sine of our angle. Now, we may also sometimes write this as tv for vertical, or t ver is equal to t sine theta.